Hello to you watching this video. So in today's video, we would be solving for wind loads using directional procedure as per NSCP 2015 code provisions. So in this problem, using directional procedure, we would be drawing the pressure diagrams for the main wind force resisting system structure shown here. Suppose that wind travels along the given x-axis. So in this problem, we have a y, z, and x-axis. And in our analysis, we are to assume that wind travels towards this direction. That makes this surface here as the windward wall, this surface here as the side wall, as well as for the back part of the building, which will also be considered as a side wall. And we'll be considering this surface here at the right of the building as the leeward wall. Okay, so for the project details, the framing to be used in this particular building is that of structural steel components. Also indicated here that it must be special moment frame. So when we say moment frame, the structural members would consist of beams and columns only. Okay, so for the building enclosure, take note here that we are to assume, this is just an assumption, we are to assume partially enclosed building. Again, this is just for lecture's sake. So take note that in this particular building here, this must actually be considered as an enclosed building because since for the events of typhoons, we are to assume that all of these windows will be closed once again in the events of typhoons. I only assume that this building is partially enclosed because I actually want to show you what will happen with the pressure diagrams. If ever some will be positive, some will be negative. And we could actually show that to you with partially enclosed structures. Hindi kasi natin mapapakita kapag enclosed yung opening natin, no? So for enclosed buildings, masyadong madali. Boring, no? Walang challenge. And ayun, no guys, again, this is just an assumption. However, guys, this might actually be the case. So this structure might also be considered as a partially enclosed building if this windows here gets destroyed during the events of typhoons. Now, wag naman po sana mangyari in real life, but if ever that these windows will get destroyed during the events of typhoons, or kaya let's say for the owners they left the windows open, from that itself the building could now be considered as a partially enclosed building. Okay, so for the story height, so per story the height will be 3.2 meters and the project location would be located in Baguio City, Philippines. Okay, so for the dimensions, for this dimension here, this is 8 meters. As for this dimension, this is 10 meters. For the height of the roof, that is 2.8 meters. And for the length of the roof along this axis, that would be 10.5 meters. So in order for us not to get overwhelmed by this model, let us simplify it using these stick figures. Okay, so with that guys, for the dimensions of the building indicated in the previous slide, it is as follows. So we have 2.8, 3.2, 3.2, 3.2 with the length of 10 meters. So again, this is the 10 meter that I am talking about. Okay, so basically we are looking at the building in front view. Okay, so again, we are to solve or we are to draw for the pressure diagram. So for the pressure diagram, as indicated in the previous video, for the windward wall, it would actually look like this. Okay, so for the first few meters, it would be constant. And it would be, or it would now increase parabolically, kind of. So it would now increase in this manner. And as for the leeward wall, it is, of course, constant. Okay, so this is constant. So we would be drawing this, and in order for us to draw that, we should know the values that we will be inputting here. Okay, so we should know how many pascals with this point B, how many pascals with this point B. And in order for us to solve for them, so by the way, let me just return these dimensions. Once again, in order for us to solve for the pressure could be solved using this equation, whereas pressure P is equal to QZ times G times CP plus minus QI times G times CPI. But take note that in order for us to solve for the value for P, we must solve for the value for QZ. So from that, the first thing that we will solve for is, of course, the value for QZ, given an equation of 0.613 KZ times KZT times KD times V squared. Okay, so again, let us emphasize on that equation first. So, getting those values one by one. So, 0.613, of course, that is already a constant. For the value for KZ, of course, that would now vary upon the height of your analysis. So, from that, guys, I would indicate a table. But as you can see that in this table, I only indicated here the values for Z, KZ, and QZ. So the reason why I did not indicate the values for KZD, KD, and V squared is that these three values would remain constant throughout the height. Okay? So first things first, let us solve for the value for KZT. So for KZT, that is the topographic factor. And it is dependent upon if your building is located on top of a hill or on top of an escarpment. But as you can see that in our building here, even though that this building is located in Baguio City, as you can see that in this particular image, it is neither in an escarpment nor in a hill. Okay? And from that, guys, it is located in a plain area on top of the plateau of Baguio. And from that, we could now conclude that the value for KZT is equal to 1.0. Okay, since of course we cannot make use of any of these values, since once again it is not located on top of an escarpment, nor a ridge or a hill. Okay, so we already have the value for KZT. What about for the value for KD? So for the value of KD, it is now dependent upon what kind of structure we are analyzing. And since it is indicated in the problem that we are to solve for the pressure for the main wind force resisting system, or MWFRS, this is now the value that we will be getting. So from that, guys, the value for KD is now equal to 0.85. Okay? So next up, so since we already have the value for KZT and KD, let us now get the value of V, or of the wind speed, or the velocity of the wind. Okay, so we have plenty of ways in order for us to get the wind speed. So the easiest way is by going to the internet or going to Google and search for this as the keyword. So DLUBAL wind load NSCP 2015. So I'm not sponsored in this video. I just make use of this website in my designs. Okay, so after searching for these keywords, click the first link for DLUBAL software, indicating wind zones of the Philippines according to NSCP 15. So upon clicking that link, it will now bring you to this interface. Okay, so what you would be doing in this interface is that you would be typing the location of your project here. Okay, so since it is in Baguio City, I typed it there. Then after which, I will be changing the map for category 3 to 5. Okay, so here in the Philippines, or here in NSCP, we actually have 5 occupancy categories. Namely, we have the essential facilities, so that is for occupancy category 1. And when you say essential facilities, it consists of the following but are not limited to. So we have fire and police stations. We have structures and shelters in emergency preparedness centers. So for example, evacuation centers. Then also hospitals, public school buildings, as long as it is essential. When we say essential, it is of topmost importance. So again, that is for occupancy category 1. So for occupancy category 2, these are for hazardous facilities. So it includes the following but are not limited to. So factories, which includes, let's say, toxic wastes, explosives. So for example, power plants, nuclear power plants, let's say factories for fireworks. As long as it is dangerous, then it is considered as occupancy category 2. So for occupancy category 3, that is for special occupancy, again, includes the following but are not limited to. So we have here educational buildings. Let's say mental hospitals, churches, and etc. So you could actually read all of the inclusions in table 103-1, occupancy category. Then for occupancy category 4, we have here the standard occupancy. So all structures housing occupancies or having functions not listed in category 1, 2, and 5. So for 5, these are private garages, carports, sheds, and fences over 1.5 meters high. So since in our structure, this is actually a residential structure, so from that, we would be considering this or our structure as category number 4. So that is the reason why in this interface, I chose category 3 to 5. Okay, so upon clicking that or typing Baguio City and clicking category 3 to 5, so Baguio or the location will now be pinned. And as you can see here, guys, since this is light blue, the velocity in kilometers per hour would be 260. Or since we need here the value in terms of meters per second, that is now in terms of 72.2 meters per second. Also, if you do not prefer this way in you solving for the basic wind speed, you could also make use of the NSCP book itself. So if you would be going to this figure, so in figure 207A.5-1A, this is for basic wind speeds for occupancy category 3, 4, and 5. Once again, in our structure, it is considered as occupancy category 4. So of course, we would be making use of this equation. And the next thing that you would be doing is that you will be pinpointing the location of your project. So if Baguio City is located somewhere here, so roughly, so as you can see that it is in between this 250 kilometer per hour line and this 260 kilometer per hour line. So for conservative measures, we could actually make use of the larger value of 260. So from that, the velocity is now equal to 260 kilometers per hour. But take note, guys, that in our equation, which is 0.613 kz kzt kdv squared, the v there must be in terms of meters per second. So from that, guys, we must convert this into meters per second. So our conversion factor that we have derived for in the previous video is that for every 1 meter per second, we have 3.6 kilometers per hour. So solving for the basic wind speed in terms of meters per second, so that is basically 260 divided by 3.6. And from that, it is 7.22 meters per second. So from that, in the next slide, we already have the value for KZT as 1, KD as 0.85, and V as 72.22 meters per second. Okay, so what about for the value for KZ? So as we know that the value for KZ will be dependent upon the height where you are analyzing. So suppose once again that this is your pressure diagram that you want to solve. If you want to solve for, let's say, this particular pressure here, the value for KZ that we will be using there is this particular Z. Okay, so this is the value for Z that we will be making use in order for us to solve for KZ. So for the value of KZ, it is given by this equation, whereas KZ is equal to 2.01 times quantity Z over ZG raised to 2 over alpha. And as you can see here, that we have the values ZG and alpha. And in order for us to know that, we will be making use of table 207E.9-1. So it is now dependent upon the exposure, okay? So this was already discussed in the previous video. So for the exposure, it is now dependent upon the location of the building. So as you can see that in this particular building, it is actually located in an urban area. So as you can see that there are plenty of buildings around. And from that, guys, we could actually consider this structure to be in an in an exposure B. So exposure B. So from that, guys, the value for alpha is equal to 7.0 and the value for ZG is equal to 365.76. Okay? So from that, we will be making use of those values in order for us to solve for KZ. So once again, for the value for KZ, this is equal to 2.01 times Z all over ZG raised to 2 over alpha, whereas alpha is equal to 7, and that ZG is equal to 365.76. Again, guys, this is only true for exposure B. Okay, so next up, also that in this equation, the minimum value for Z is either 4.5 or 4.57 depending upon what page of NSCP you're referring to. So actually, if you would be considering 4.5 is correct and 4.57 is still correct depending once again on what part of the NSCP book you are referring to. But in this lecture 6, we will be making use of a Z min equal to 4.5. Ibig sabihin yan po yung pinakamababang Z na pwede natin gamitin. Okay? So, going back to this table, so let us solve for the value for KZ for the first row, which is that for 0. So, meaning that we are actually solving for the QZ at this location at the height of equal to 0. So, what I would be doing is that I would be typing the equation in my calculator. So, 2.01 times, so, again, 2.01 times Z. So, I will be assigning alpha x here in order for me just to change the value of Z as I go to the next data. So, alpha x over ZG is 365.76 raised to 2 all over alpha. And for the alpha, that is 7. Okay? So, for the first one, if you are thinking that you would be substituting, let's say, the value for x as 0 or z is equal to 0, then that is wrong because once again, the minimum value for z should be 4.5, okay? So from that, for the first data here, we would be making use of a value of z as 4.5. So from that, guys, the answer here is 0.5721. Okay? So as for the next one, as you can see, the 3.2 meters is still less than 4.5. Meaning that in my solution below me, we would still be making use of z equal to 4.5. So meaning, if you would still be getting the answer, same answer as what is written below me. So from that, this is still 0.5721. And if z is equal to 4.5, so that is actually the minimum. So from that, this is 0.5721. Okay? So next up, for 6.4, as we know that 6.4 is actually greater than 4.5 already. So from that, I will be changing the value of x by pressing the calc button and I will be typing 6.4. Enter. Then from that, we would now be having an answer of 0.6327. Then, with the height of 9.6, again, just press calc in my calculator, then type 9.6. Then from that, the answer is 0.7104. Okay, so in here, guys, you also need to know the value of h mean. So when we say h mean, that is the mean height of the building. So it is not the entire height. Rather, it is measured from the ground up until the center of the roof or the midpoint of the roof. So take note, guys, that we do not actually need to get the centroid of the triangle via variance theorem. Rather, it is much simpler than that. What we would be doing is that we would be measuring from the ground up until half span of the roofing. So if this is 2.8 meters, so meaning that this is 1.4 and this is also 1.4. So from that, for the h mean or the mean roof height, that is given by, so 3.2 times 3, so we have 3 floors, plus half of the roof. So 1.4. So from that, the value for H mean would now be equal to 11 meters. So let us solve for the value for QZ at H or QH. So from that, guys, going back to our equation earlier, so in this equation, I will be pressing calc and I will be solving for the value for KZ if the value for Z is 11. So from that, that is 0.7386. Okay. So from that, guys, we could actually solve for the value for QZ already. Okay, so from that, I will now be changing the equation in my calculator as 0.613 times KZ. So KZ would vary. So depending upon the height, KZ would vary. So I would type alpha x once again. Times KZT, KZT would be constant as 1 regardless of the height. KD is also 0.85. And the velocity would be 72.22 quantity squared. Okay, so pressing calc, for if kz is equal to 0.5721, the answer here is 1554, 1554.7706. Okay, so same is true as with these three because three of these values have the same kz. So 1554.77, 1554.77. Then for the value of 6.4, so I would be pressing calc, and what is the kz for 6.4? That is 0.6327. So that is 1719.46. Then lastly, for the last one, for QZ at 9.6, so calc 0.7104. That is 1930.62. Then lastly, for H mean. So that is, so pressing calc, then 0.7386. Okay, so that is 2007.26. Okay, so proceeding. So since we already know the value for Qs, if you're thinking that this is already the pressure that we will be inputting here, then you are wrong. Again, this is just the velocity pressure. We must multiply it first by the gust factor until gust factor, the wall coefficients, and etc. in order for us to get the effective pressure. Okay, so proceeding. So I have already listed here all of the answers or all of our answers a while ago. So we will now focus on this equation. So as you can see, we already have the value for QZ. Next up, let us solve for the value of G. Okay, so when we say G, that is the gust factor. And for the value of gust factor, we could actually make use of a gust factor equal to 0.85. But take note that this is only for rigid structures. So when we say rigid structures, these are structures which has a natural frequency of natural frequency of greater than equal to 1.0 hertz. So yan po, dapat po mas mataas sa 1 hertz yung frequency niya. What that means is that the minimum number of vibrations for every 1 second. So when we say hertz, this is vibes or vibrations per second. Okay, so it is actually the inverse of period, because for period, that is the number of seconds per vibration. Okay, so in order for us to solve for it, as per NSCP 2015, we are to make use of these equations. But I just want to disclaim that in my previous video lectures, I just made use of this equation from NSCP 2015 first printing. However, guys, this might have some typographical errors because this formula here can only be used if, let's say, your height is in terms of feet. Okay, so again, if you would just be making use of this equation, regardless, so if NA is equal to 22.2 divided by H, and the height, the mean roof height of our building is 11 raised to 0.8, the answer here is, what do you call this? The answer here is 22.2 over 11 raised to 0.8. So this is now 3.26 hertz. Okay. However, guys, once again, that this equation here is in terms of feet. So from that, guys, this is rather erroneous. So again, if this is in terms of feet, let us just convert it into feet first before making use of this equation. So from that, guys, the value of NA is now equal to 22.2 divided by the height is 11 meters, and if we would be converting it into feet, we would be multiplying it by 3.28 feet per 1 meter raised to zero point 0.8. So the answer here is, I think it is above 1. So this is 22.2 divided by 11 times 3.28. Oops, sorry. This must be raised to 0.8. So 0.8. So from that, guys, the natural frequency is 1.26, and that is greater than 1. From that, guys, we could now conclude that our structure is rigid. Okay? So if you're that kind of person who likes to memorize formulas, instead of you converting it, let us simplify this particular equation. So if I am to erase everything. So again, guys, before I erase it, take note that we will be considering our structure as rigid. Okay? So again, if we are to simplify this equation, Na, this once again equal to, so 22.2 divided by, let's say that the height that you want to use is in terms of meters, so h. But then again, we must convert it into feet first, raised to 0 0.8. Okay? So, as you can see that we could actually simplify this equation here. Then from that, NA is now equal to, so simplifying the values that I have encircled, so that is 22.2 divided by 3.28 raised to 0.8. So from that, this is 8.533 8.5833 all over h raised to 0.8. Okay, so you could actually memorize this if you're that kind of person who likes to memorize things. But if not, and if you prefer memorizing this equation, just take note that this h here must be in terms of feet, as well as for this h here, and as well as for this particular h here. Okay, so from that, we already know the value of g. So what about for the value of, let's say, if we are to go back here. So since we already know the value of g, what about for the value for Cp? So for the value of Cp, it is now indicated in this particular table. So it is dependent upon what surface we are analyzing. And right now, we are analyzing for it in terms of windward walls. So let us first analyze windward walls before the other two. So that is for Cp. So for Qi, this is the value of Q that we will be making use in order for us to incorporate the internal pressure. So going back here or going here, so if we are to solve for the negative internal pressure, Qi is equal to QH. What is QH? That is the value of Q at height H. And in our case a while ago, this is H min. Okay. So for positive internal pressure, we would be making use of Qi is equal to Qz, where Z is the highest opening in the building that could affect the positive internal pressure. However, it is not indicated in the problem where that location is. So from that, guys, also it is allowed in the code that Qi may be conservatively be evaluated at height. Qi is equal to QH. So from that, guys, let us just conservatively use Qi is equal to QH. Okay, so that is for Qi. So for GCPI, this is now dependent upon the enclosure classification. So for the enclosure classification, it is located here. Okay, so let us fill up all of the values that we could fill up. So for the value for G, again, this is 0.85. It would be constant throughout. And if we are to solve for the windward pressure diagram, the value of Cp, once again, is included here. So since we are to make use of the windward wall, the value for Cp that we will be using is 0.8. And from it, the value here would be 0.8. Actually, for all of these values, 0.8. Okay, so for the value for Qi, again, conservatively speaking, we could make use of QH. And what is QH? QH is, if this is H mean, then this is QH. Okay? So from that, this is 2007.26, which we will be using for all of the values here. Then for GCPI, again, it is seen in this table. So again, in our problem, we are to assume that the enclosure is partially enclosed, but in real life, guys, the building must actually be enclosed. But then again, for lecture purposes, let us assume that it is partially enclosed. And from that, it is positive or negative 0.55. So going back here, so I will assume for a value of 0.55 first. Then for the negative 0.55, I will be solving for that later. Okay, so from that, guys, since all of the values have already been filled up, let us now solve for the value for P. So again, same old method. So that is QZ. So QZ varies, so alpha X times G, that is 0.85, times CP, that is 0.8. So I will be using plus first before the negative sign. So kasi nga 'di ba yung GCPI, that is positive negative, so I will be solving for the positive first. So plus QI, and again QI is equal to QH, which is 2007.26, times GCPI of 0.55. Okay, or maybe I think it would be better for the first one, I would be making use of the negative value first. So negative GCPI first. So what that means is that for the negative GCPI, we are to consider that the pressure outside the building is less than the pressure inside. So later on that, let us solve for the values first before I explain it. So from that, guys, pressing calc, what is X? That is 1554.771. So, oops, sorry. This must be negative, I should say. So, negative. So, minus po muna to. Or better yet, plus negative 0.55. Okay? So, getting the answer here, we would be arriving at an answer of negative 46.749. As well as for this one here, since those three would be having the same values for QZ. Next up, so calc, then for the next one, that is 1719.46. So take note, guys, that we are just changing the values for QZ. So enter, so this is now 65.2398. Then lastly, so calc, then 1930.622, that is 208.833. Okay, so from that, guys, if you would be graphing them, it would actually look like this. So for at Z is equal to 0, the pressure is equal to negative 46.749. So what a negative value indicates is that it is a suction pressure. When we say suction, parang hinihigop palabas yung building nyo. Okay? So from that, as you can see here, so in this scenario, so since this is negative 46.749, it must be directed away from the building. So negative 46.749. And as you can see, guys, that up until 4.5 meters, they have the same pressure. That is why this is uniformly distributed. Okay. Next up, for a 6.4 meter height, which is at this location here, the pressure is now positive 65.24. 65 pressure indicates that it is a direct pressure or tinutulak niya yung structure. So from that, guys, this here is positive 65.24. Then at the height of 9.6 meters, this is now, this here is 208.83. And again, for these values, these are in terms of pascals. Okay, so if you're wondering, so in my drawing a while ago for the sample for the pressure, it is like this. Whereas for this first part, it is pushing the building towards this direction. And as for this part, it is still pushing it towards this direction. But in the values that I have solved for here, whereas we have a negative value, so bakit baliktad na ngayon? So how is that possible if this is, let's say, the wind speed or the wind direction? Okay, so take note guys that in our example, it is partially enclosed. When we say partially, in Tagalog, medyo lang. So meaning that there are some openings, but it is still closed. So there would be some openings and some would be closed. So if that is the case, so what happens here is that, for example, guys, that there are, let's say, opening at this direction or at this window. And when it winds, or wait lang, tama ba grammar ko? If humangin po, if there is the presence of wind, if this here is partially open, some wind will be entering the building. And from that, if it would enter the building, guys, it would actually build up pressure here. So, pressure would now build up. And if the pressure inside the building is greater than the pressure outside the building, like in my previous video, yung tawag dito, yung sa part ng lobo pati nung lata. So in that case, guys, if the pressure inside the building would be greater than the pressure outside the building, this internal pressure or the internal pressure at this side has a tendency to push the building outside. Okay? So in that case, if it has that tendency to push the building from inside out, as you can see here, this would actually have a pressure at this point. Okay? So what happened here is that, okay, so for this particular equation, here for QZ times GCP, this is the external pressure. Okay? So if that is the external pressure, this is this pressure. Okay? And in order for us to solve for that, again, that is QZ times G times CP. So the QZ at the first floor is 1554.771 times G of 0.85 times CP of 0.8. So that is a positive of 1057.244. When we say positive, meaning that it is pushing the building from outside, okay? And as for this value, okay, so for this particular value, this is the internal pressure. So internal. So if that is the internal pressure, for QI, that is 2007.26 times, so for the GCPI that I have used, that is negative 0.55. So for negative 0.55, that would now have an answer of negative 1103.993. So meaning by negative 1103, it is, again, pushing the building from inside out, or parang suction pressure siya, hinihigop siya nung labas. So from that, guys, this is negative 1103.993. Okay, so as you can see that in this location that they are opposite each other, and from that we could actually solve for the resultant. So for the resultant, guys, that is 1057.244 minus 1103.993. So from that, the resultant is negative 46.749. So meaning that in this figure here, this is already the resultant. So both the external pressure and the internal pressure was already, is being taken into consideration in that graph. Okay? So that is still possible kapag po malaki na yung pressure sa loob masyado as compared with outside. So that would happen actually. So that would happen if and only if the pressure inside would be greater than that of the outside. Okay, so next up, if we are now to draw the windward pressure diagram with a positive GCPI. So what will happen here is that we would just be changing the GCPI into a positive value. So meaning, guys, if positive value, if let's say that this is the external pressure, the internal pressure would also be the same. Okay? So they would now be the same direction, And if you would be mathematically computing for it, it would just add. Okay? So in that case, looking at the calculator, so that is alpha x times g, that is 0.85, times cp, that is 0.8, plus 2007.26 times 0.55, which is positive. So from that, if the QZ is 1554.771, that is 2161.237, and etc. If you would be solving for everything, guys, we would now be arriving at these answers. And as you can see, all of them would be positive. And even though that all of them would be positive, the first few meters up until 4.5 meters, they would still be positive. And then, they would be the same, they would be constant. But as we progress from 4.5 meters, guys, they would be increasing. And from that, guys, for this first few parts, this is 2161.24 pascals. Take note, pascals, not kilopascals. Then at a height of 6.4 meters at this location, the pressure here is 2273.23. Again, this is pascals. Then for the last one, this is 2416.82 or 2.416 kilopascal. So take note, guys, this is kilopascal, this is pascal. Okay? So that is how you would be drawing the leeward pressure diagrams. Okay? That is how you would be drawing the windward pressure diagrams. So there.